Welcome to our NPTEL lectures on the power quality improvement technique. We are continuing to discuss with the passive filter, that will be, this will be our second lectures. So, we are discussing about the passive shunt filters. So, this kind of network, just RC network, we will say it is a first order system and it will give you a 20 dB decade, and of course its transfer function is, this is the transfer function. So, ultimately you can see that with, if you connect a load parallel to it, this impedance will go down with the increasing frequency, and thus it itself is a high pass filter. So, for this reason shunt damped or the high pass filter, it will generally eliminate the high pass filters and DC part will be there. That it can have a second order filter, it will give you a 40 dB decade, and generally you will have a transfer function of S plus A plus S minus plus B. It can have a complex conjugate also. So, these will essentially set a 40 dB decade, and this is also mostly, if it is generally A and B are same. So, it will have a complex conjugate, generally it will have k a square plus omega square, this kind of entity. If it is in a undamped quantity, otherwise if you have since you have added a resistance, it will be a damped quantity. So, you can expect that. So, the roots will be complex conjugate also, but you can split it like this, roots will not be same. So, this will gives you the 40 dB decay of this high pass filter. So, it will have a very sharp decay, and this is the third order filter. So, you got a L and C, this combination will give you a 40 dB decade, and with that this will be the another 20 dB. So, total will be the 60 dB decade, and this is a C type filters, is a special kind of filter. Here you can see that L and C, you can go back, we have talked about the first talked about the L and C filter for the single tune. So, it is, this part is essentially the single tune filter, it has been tuned to the particular frequency, and this is essentially this. So, it is a combination of this high pass and a particularly tuned filter. So, this type of filter is said to be the C type filter. You want to eliminate switching frequency, and for that this filters. Apart from that, you want to eliminate fifth harmonic. So, due to that this will have a this L and C, then this kind of combination is said to be the C type filters. Let us see how it will behave. So, you have the band pass filter, and you will ultimately this will sync to this particular A, and it will give you the anti resonance. So, particular value of the omega, and you require to damp it properly, otherwise there will be a very sharp anti resonance. Similarly, you can have a high pass filter with this combination, and thus response will be like this. So, first of all there will be a notches. So, this is the impedance. So, admittance will be maximum at that point, and thereafter it will reach there, and this is a doubled band pass filter. So, you will have the maximum admittance here and minimum admittance on opposite position. So, it is a minimum impedance and this is a minimum impedance, and when you got a minimum impedance, so it will be a sync to the fifth harmonic or seventh harmonic. So, you can eliminate both. and you can have a composite. So, you have this and this, thereafter this, then you can eliminate the any other frequencies like this. This will be a zigzag line. Passive filters are connected in now let us talk about the series passive filters. We generally prefer the shunt passive filters because of the anti-resonance, and you bypass this, it will provide the sink for the high frequency. So, just reverse required to do in case of the series passive filter. Let us see the, and also there is a problem of the transient because you can have a series resonance. So, that will increase the value of the current. The passive series filters are connected in series with the harmonic producing load to provide high impedance for the blocking the harmonic current. So, it will not allow fifth harmonic to flow into the grid. The passive series filter is a simple LC parallel circuits. It is quite easy. At fundamental frequency, the filter designed to offer very low impedance, hence fundamental current is negligible, and voltage drop also the losses are also negligible. But problem lies, since it is in series, it sees the whole current through it. So, it will see the full rating of the current, that is what it is. So, this filter must be designed to carry full rated current with the overcurrent protection. So, this is one of the major drawback of the series filters, its rating required to be higher. At fundamental frequency, this consumes lagging reactive power, resulting further drop into the system. Hence, and for this you do not use it, hence that shunt filter is much cheaper than the series filter, and it has these demerits. So, this is the one example. You refer to the fax devices also. So, TCSC, all those devices, series compensation devices, it is an extension of the series passive filter. So, series passive filter tuned to the tuned or band block filter, this is C1 and this is R and L1, this is L1 and C1, and this is a single tuned, it can block fifth harmonic, it can block fifth and seventh harmonic, and this is a series passive damped high block filter. It will allow this low frequency to pass, but it will block the high frequency. That is the way it should operate. Now, you can have a hybrid passive filters. Of course, you can have a combination of it. Sometimes T filter, pi filters, these are the topologies we here very frequently use that. So, hybrid filter consisting of a series and the shunt filters, it can overcome individual drawback of both passive shunt and the passive series filters. Passive filters rating is less, but there is a problem of the anti-resonance, and in case of the series filter it sees the total rating and cost is high. The passive hybrid filter consisting of a single tuned passive series and a single tune passive shunt and a high pass passive shunt filter. So, there is a permutation combinations are possible in it. So, you can have many combinations. So, single tune passive filters is able to block resonance between the supply and the passive shunt filters and absorbs the excessive reactive power of the passive shunt filter at light load condition. So, this is the demerits of the conditions of the shunt filter that can be eliminated by the combination of the shunt and the series filter. So, this is the combination of the hybrid passive filters. So, you can have a series filter, with that you can have a shunt filter, and this is a double tuned. Similarly, you can put it like this L1 C1, this will give you a combinations of this one, L2 C2 will give you some combination L3 C3, and thereafter you can have a RC network will bypass the switching mainly. So, those kind of combinations are possible here. So, this is one of the combinations I am showing you. The hybrid filter is a combination of the passive series and passive shunt. So, this one is a passive series and this one is a passive shunt. You have a nonlinear load. So, it will block maybe the fifth harmonic. So, fifth harmonic will not able to pass on this direction, and it will provide the path for the fifth harmonic to sink. Ultimately, fifth harmonic will be drastically reduced. Hybrid filter as a combination of the passive series, that is, we say that passive filter of series and the passive shunt and the passive series filters. So, this is called the T network. So, it is, that is what I was saying, this network is called the T network, and there is also an advantage of it. So, this L1 and this L1 and this C1 forms a network, and this C1, this C2 and this L2 forms another network. So, ultimately this L1, L2 and C1 can be combined to eliminate a particular harmonic. This itself can be tuned to eliminate a particular harmonic, and this can block a particular harmonic. This also block a particular harmonic, and this combination can allow to sync a particular harmonic. So, this has enough capabilities. So, inside it, this can provide high impedance, let us say the 7th harmonic. This can provide the high impedance for the 5th harmonic individually, and moreover these combinations can allow this L1, L2 and C1 can be a sync for the 5th harmonic. Same way C1, C2 and L2 can be a sync for the 7th harmonic. So, you are not allowing to 7th harmonic to pass through it, and whatever you are getting, it been trapped here. So, in that way you can improve your power quality problem. Same way, this is called pi network. We are using the pi network from the rectifications of the circuits, because you have a diode based rectifier. Thereafter what you do, you put these two kind of capacitors, and in between there is an inductor. So, it is nothing new to you. Before that you have a diode based rectifier. You are studying this circuit from maybe at the basic level of the engineering. So, here also the same thing. So, this network is called the pi network, this network is called the T network. The hybrid filter is a combination of the passive shunt PSHS1 and the passive series PFSS and the passive shunt network. So, same way you have this C1, C2 and this L, it can eliminate a particular frequency, and same way this L and C will also behave as a band pass, low pass, and many combination is possible also. Here we generally prefer this network over this, because you can provide, let us say this is a sink for the fifth harmonic, and it is little bit of band pass filter, you actually provide high impedance to the both fifth and seventh harmonic, and here you provide sink to the seventh harmonic. But here you have trapped the seventh harmonic, but it is not getting a path to flow. Here you have provided the drainage for the fifth harmonic. So, and also if you see the component count, here component count is less. So, anyway, each has its own advantage and disadvantage. We can go into the detail when you will design this for a particular problem. Now, based on our discussions, passive power filters can be based on the phases. You can have a single phase that is put into the distribution system, that is shunt, series and the hybrid. And you can have in a transmission system mainly, in a HVDC line and others, that is for the 3-phase 3-way system, and you can have a shunt, also series and hybrid same, and you can have a 3-phase 4-way system in 440 volt line. So, you can have a shunt that is connected in between the all line to the neutral, all the combination we will see. Series it is fine because it will be in the line, but hybrid we can see the combination, we can put it between two lines, also you can put with the line to the neutral. Now, this is the one of the example of the single phase passive shunt filter. So, here this is your source impedance, and you can see that this is the block, inside it you have put that filter. This has been tuned to the particular harmonic, this has been tuned to the particular harmonic, and this is a combination of harmonic, we already discussed this. Fifth, seventh, thereafter all the higher order harmonic can be sink into the system. So, this is the way of doing it. So, you will have a third harmonic. So, for this reason this filter has to be the sinking path for the third harmonic, this is a filtering path for the fifth harmonic, and the order all the higher order harmonic above fifth will be sink through this high pass filter, because it will sink all the high pass frequencies. Same way, since it is a 3-phase 3-way system, you have a harmonic content is 6n plus minus 1, that is your first, thereafter 5th, 7, 11, 13. So, for this reason it is in a star combination. So, it is connected in between 3 lines and it will be tuned to the fifth harmonic. Same way, this will be tuned to the seventh harmonic, and all the other harmonic will be eliminated by this filter above 7. Similarly, we can have a classifications of the passive filters based on the series network also. This can eliminate third, because it is producing the harmonic source. So, it will not able to flow here, and this will have a fifth, this will have all the high frequencies. So, current only fundamental will flow and others will generate it, and similarly this one for the other phases, and this one will have a neutral aspect of it. This is a way of connecting 3-phase 4-wire system with the passive. So, you see the component count and thus you will appreciate the shunt active power filter. So, you require huge number of the component. Similarly, we can do it with the passive filter. So, you have this is the fifth harmonic, this is this is third harmonic, thereafter this is the fifth harmonic, this is the combinations of the all the higher order harmonic and that is the feeding. So, this will provide the path for syncage for the higher order harmonic. Now, objective, the operations of the passive filter, how it has been done. You have some harmonic source and thus it will sync the harmonic here and you have a AC network that will be free from the harmonic. That is a way it has been designed. So, reduction of the harmonic voltage and current to a standard level, the basic operations and the principle of the passive shunt harmonic filter is to absorb harmonic current tuned by the LC filter. That is the way we do it. But problem of the LC filter is now we have not come into that discussion, that is the derating. The value of the capacitor will gradually reduce because of their, since C equal to epsilon 0 epsilon r A by D, what happened, you got a dielectric in between. So, dielectric strength, because D is in micrometers. So, it is a very thin one in some microns, and thus what happened, gradually it will start decaying. And also inductor, it depends on the rating of the current, these wires are burnished. So, burnish also if you keep it into the raw wire, that is what it is subjected to be, and this burnish will go out, and that is what happen, it will derate, and the value which you are designing, after that you will find that it is not able to mitigate that particularly tuned, and if the sharpness is very high, then it will fail to operate properly. So, similarly, the basic operating principle of the passive filters is a block of harmonic current entering to a AC network by a passive tune parallel LC filter. The passive sun connected circuit absorbs a part of a harmonic current and a fraction of the harmonic current still flows into the network, and therefore, it reduces the harmonic current and does not completely eliminate them, but we have read the standard of the power quality, we do not say that we require to eliminate them, it is up to some level that is dangerous. So, if you can keep below it, you can work with it. And also this is something very important, the location of the placing of the passive filter, where you will place, where, and that nowadays done by the harmonic load flow study, and you have a saddle point of the particular harmonic in a, because you have considered a one line system, practically it is not so, it is a multi-bus system, and you require to run the load flow study. From the load flow study, you require to find it at the saddle point where the strength of the fifth harmonic is maximum in a particular bus, and in that bus you will connect the particular filter. So, in that case we are assuming that is a single line, only single bus system. The passive filters are located very close to the load. That has to be something we require to say, that we have to put it, we have to trap them very close to the its originates. You should not allow to propagate, then none of interference will come. For example, you have a adjustable speed drive and parallel to it there is another load, and if you connect a passive filter here, this is ASD and this is the linear load, maybe a motor without a switching frequency. Then what happened, this fifth harmonic which is sinking here will also flow, so it will interact with this linear load. So, for this reason we say that most of the time passive filters are connected. The point of common coupling we will discuss in detail in case of the shunt active power filter, where loads are connected and sometimes they are connected to the tertiary winding of the transformer, designed for the purpose of the optimum voltage to reduce the cost and increase the effectiveness of the properly designed leakage inductance of the tertiary winding. That we will see that this leakage inductance of the we do not want the inductance in the transformer, that will be lossy one. If we see that there is a sufficient value of the inductance in a transformer, it is because of the leakage of the flux, and that we do not want. In a good designed transformer should have a very low leakage reactance, and for this reason we want another winding, that will be a tertiary winding with a high leakage inductance, and with that capacitor will be connected and its rating will be low also. In that way we can give you a solution. Anyway, we shall continue this discussion from our next class, that is the location of the transformer, location of the placing of the transformer of the tertiary winding along with the this passive filters. Thank you for your attention. I continue this discussions of the passive filter also in the next class.